Hi, good afternoon, everybody. You guys can hear me?
Yes, sir.
All right, we're starting like in a minute from now. Just wait. Let me see who else will come on. Then we'll make a start. All right, so last class we started looking at addition and subtraction of algebraic fractions, right? So we're gonna do some more so that you guys can fully understand the concepts. So last week we started looking at ones looking like this. We had 2x upon, let's say, 6 plus, say, x upon 4 plus x upon, let me see, 3. Good. So what's the first thing we need to do? Anybody? Again, this is algebraic fraction, the combination of algebra and fractions.
Find the LCM.
Exactly. So normally with fractions, all we got to do, the first step is to basically find the LCM, right? So in this case, we're dealing with numbers, and you will see for the next example, you will need to know how to find the LCM using numbers and variables and so forth, right? So this one is straightforward. This is the one that you're accustomed to seeing, finding the LCM of 3 numbers, 4 numbers, 2 numbers, and so forth, all right? So what's the LCM of 6, 4, and 3? What's the LCM of 6, 4, and 3?
12.
Anybody else? 12 is it, right?
Yes, sir.
All right, so 12 is the LCM. Good. And what's the next step? We basically divide the 12 by these individual denominators, and then we multiply it by the numerators, right? So what we say 6 into 12 is 2. All right, so we take that 2 and we multiply it by the numerator. All right? Everybody get that?
Yes, sir.
Good. So tell me now, we need to multiply this. 2 times 2x. Anybody? What's the answer? We did multiplication of algebraic terms.
4x.
4x. Excellent. So we take that 4x and we put it here. Plus, then we do the next one. 4 into 3 is how much? 4 into 12, sorry, is 3. I give you the answer. So it's 3. Then we multiply 3 times x and we get 3x. All right?
Yes,
Everybody
sir.
get that? Good. Then we divide the 3 into 12 now, and we end up with 4. We use the 4 and we multiply it by its numerator. Right? 4 times 3, 4 times x is how much?
4x.
Excellent. And all we got to do now is to add the variables or the terms. 4x plus 3x plus 4x to give me how much? Algebra, remember, addition of algebraic terms. So we basically added them. 4 plus 3 plus 4. Give me how much?
11.
It's going to be 11x. All right? So 11x upon 12 is our answer. All right? So this is the simpler ones, right? So let me give you guys one here. It's more like the reverse. So instead of having the numbers at the bottom, you put the numbers at the top. And put the terms, x terms at the bottom. Let me see what you guys think. So take this down, and this is the one that we will apply. So I want you guys to understand every concept when it comes to using algebra when doing fractions. All right, so we have these types. When you see this, you must know what to do. So take this down, think about it, and then we work it together. So we have 3 upon x plus 4 upon 3x plus 5 upon 4x. Good. Anybody? What's the first thing we need to do in this case? Anybody? Nothing too complicated. It's the same procedure. Huh?
Are the same thing?
Good. So what's the LCM of x, 3x, and 4x?
12x.
12x. Anybody else with anything different? Anybody else with anything different?
No, sir.
Wow, yeah, bright man. All right, so indeed it's 12x. So what we do, we look at the numbers, right? We look at the numbers that we have at the bottom. We have a 1 here. We have a 3. We have a 4, right? See that? So we find the LCM of the numbers. And the LCM of the numbers, 1, 3, and 4 is 12, right? Then we look at the variables that we're dealing with. We're dealing with x term or look at the term that we're dealing with. We're dealing with the x term, right? So indeed, it got to be 12x. That is the only term we're dealing with. Right? If we're dealing with two terms, if you notice that you see two terms or x or y, it got to be an xy. If you notice that you see PQ, it got to be PQ, but the only term that we're dealing with is x, so it got to be 12x. Right? Remember, we only do this when you see terms or we say letters at the bottom, right? But in this case, you don't have to worry about x and all of these things because we're defining the LCM and we find the LCM using these here, the denominators, right? Good. So 12x is it, right? So we use the same procedure. We use the same procedure, right? Use the individual denominators, x, 3x, 4x, right? And we divide it into the 12x. So the first one, we say 12x divided by the x, right? You see? 12x divided by the x, right? And all we get when we divide that, the x in cancelled. Remember when we did division of algebraic terms?
I get 12.
And you get 12, right? So for this here, we use this 12 and we multiply it at with the numerator, right? It's the same thing. Huh?
What?
Wanna do it back?
Yes, sir.
All right. No problem. All right. So, all right. So again, you understand how we get the 12x, the LCM?
Yes, sir.
Good. So remember, in this case over here, all we do is divide the 12 by the 6, right? And we get 12 divided by 6 is 2. And we use the 2 and we multiply it by the numerator, right? See here on this side. Similarly, we're using the denominator, which is, but in this case is 12x, not 12. And we divide it by the x, right? And this is what we get here. 12x divided by x, the two x and cancel out, and we get 12. 12 and left back here, right? Remember division. Remember when we did division, what we got to do? All we just actually apply them, right? So the 12x divided by x give me 12.
Sir.
Yeah.
You said last class, right? Whenever there's an x alone, you put 1 next to the x. Does that apply for all rules in algebra?
When there's an x alone, you put 1.
Yeah.
Or like
There's a 1 in front of x.
Yeah, there's a 1. This is understood.
No. I know, but does that apply for every equation?
Yeah, if I have y alone, if I have x alone, if I have p alone, it simply means that the 1 is in front of you.
Right.
Right? These are
Yes, sir.
nothing too complicated. Right? So everybody understand how we get the 12, right? And we use the 12 and we multiply it by the 3, by the numerator. So it could be 12 multiplied by 3 is how much? All right? So we multiply that. Then we do the same thing with the rest, right? So it's 3 times 12, you get 36, then we add. Then we do the same thing with the next set. So we say 12x divided by this denominator now, which is 3x. Right? So 12x divided by 3x as well. Anybody? You divide the numbers, then the x then you cancel out. So basically 12 divided by 3 is how much?
4.
4. Remember, you gotta know how to divide. So we use the 4 and we multiply it with the numerator. Right? So 4 times 4 is 16. Good. Then you do the last one now. 12x divided by 4x. We divide the two coefficient or the two numbers that you see. The 12 divided by 4 as well. 3, right? And then the x can cancel out. So we left with 3. So we use the same 3 and we multiply it now by the numerator. So 3 times 5 is
15.
15, right? So we add all of these and the answer, you can get your answer. So we add 36 plus 16 plus 15 is how much? Somebody.
So 67.
67.
Good. So we have 67 divided by 12x. So that's the answer, right? So nothing too difficult. You just gotta remember how you use algebraic terms when you're dividing, when you're multiplying, and so forth. Nothing too difficult, right? So persons who can get this, take this down, and then we do a next one with a little twist in it, right? All right, so take this down. X divided by 3y plus 2 divided by 4x. And tell me what is the LCM from this to addition of algebraic fraction? What will be the LCM?
12xy.
12xy. Anybody with anything different?
No, sir.
All right, yeah, right, man. Yeah, sure.
Yes, sir.
All right. So again, we find the LCM for the two numbers, right? This is how you do it. 3 and 4, the LCM for 3 and 4 is 12. Right? We know that. Then we look to see what terms we are dealing with. Right? In this case, over here, we're only dealing with x. So this is the reason why we have to add x there. But in this case, we're dealing with the x and we're dealing with the y. All right, so therefore it can be xy. Right? Good. So 12xy is our LCM. Everybody get that?
Yes, sir.
Yes, sir.
Good. So then we use the same procedure. We use the same procedure. We divide the common denominator, which is the 12xy, by these individual denominators. So we have 12xy divided by 3y, right? What would be the answer there? 12xy divided by 3y.
4, sir.
4x.
Huh?
4x.
4x.
Good.
4x.
The number with the numbers will give us 4 because 12 divided by 3 give me 4. And then you notice that you gotta cancel with the y, cancel the y. And you're left with an x, so it could be 4x. And the x is at the top, right? So it could be 4x. All right. So remember when we divided numbers, right? The result from the number is be at the top, right? So this is the reason why the 4 will be with the x. So it can be 4x, right? So we use this 4x and we multiply it by the numerator. So what we have in here is 4x multiplied by x, and that will give me what?
4x.
Algebra. When we multiply
4x
algebra, 4x squared. Remember
4x.
when we multiplying algebraic terms, is like it coming together. So it could be like 4xx. But you don't say xx because they're the same term. So we just put the x squared, right? Because there are two x's. All right, so it could be 4x squared will be the result, right? Then we do the same thing. We have 12xy divided by this denominator now, 4x. Right? So we divide the numbers, what we get? 3, right? 12 divided by 4 is 3.
Yes, sir.
Good. Then we find that we have 2 x's here. So we cancel them out because they are dividing. And what we left with y? So it's 3y we left with, right? So now
Yes, sir.
we have 3y here. So we gotta multiply the 2 by 3y. So what will be the answer? 2 times 3y.
6y.
6y, excellent. Good. Question. What will be the result? Anything else we need to do here? Or this is the answer? Can we add these two at the top?
No, sir.
No.
Why?
Because they're unlike terms.
Sir.
Exactly, they are unlike terms. So that would be our answer. We can't go further than that. Right? We noticed for the previous example that we do, or the first one that we do, we had this like terms at the top. So we could just add them and get one thing. But in this case, we have an x squared and a y, and they are unlike. So we can't do nothing with that. So the answer would therefore be 4x squared plus 6y divided by 12xy. That will be the answer. Right? So I'm gonna give you guys one to do on your own. All right, I give you guys one to do on your own. And I'm gonna see what you guys gonna do. Give you guys like 4 minutes to complete it, all right? Let me see if I can put it right here. So what we have here, I want you guys to work 7 divided by 9 PQ, 7 divided by 9 PQ plus 5 divided by 18P. 5 divided by 18P. So look at it, think about it, give you guys 4 minutes to attempt it and get the result, right? And then we work it together. All right. So question, looking at this, what would be our LCM?
18.
18 well. So the numbers will give us 18, right? Agree 9 and 18. The LCM will give me 18, right?
Yes, sir.
And what terms we are dealing with?
PQ.
Huh? We're dealing with a P and we're dealing with a Q. Right? These are two letters you see, right? P and Q. Right? So it could be PQ. It doesn't matter it's how much P or how much Q. Once you see P and you see Q, just put PQ. Right? So it's 18 PQ. Everybody get it clear?
Yes, sir.
Yes, sir.
Good. Then do the same thing. We say 18 PQ divided by this denominator here to know what we need to use to multiply by the numerator. So we say 18 PQ divided by 9 PQ. Right? That will give me what? The P cancel with the P, Q cancel with Q.
2, sir.
So you just left with 18 divided by 9, give me 2. Right? Because the letters cancel, all two of them cancel each other, right? So the 2, we use the 2 and we multiply it at the top. It says 2 times 17, give me 14. Then we do the same thing, but in this case, we're using 18P, this one here.
Sir,
Right.
please excuse me. Can you please go it over back for me a little bit?
All right, no problem. So You understand how we get 18 PQ for the LCM?
Yes, sir. I understand. Yeah.
Good. So what we need to do is to use this denominator or the LCM and divide it by this denominator here. Right? You understand how we get
Okay,
this?
sir. Yes, sir.
Good. So this is what we divide. And you notice we have two terms canceling each other, right? So the P will cancel with the P
Yes, sir.
and the Q will cancel with the Q.
And the Q.
So all you got to do is divide the
Okay.
numbers. 18 divided by 9 will give me what? 2, right?
Yes, sir.
Good. And we use the 2 and we multiply it by the numerator, which is 7. So 2 times 7 is
Okay, sir.
14. The same is fractions. The only difference is we're dealing with terms. So it can be algebra, we got to apply also. So we do
Yes,
the
sir.
same
Thank
thing
you.
using, all right, we do the same thing using this denominator now, 18p. Right? So we say 18
Yes, sir.
PQ divided by 18p. So what would be our answer there? Anybody? What would be the answer there?
5.
80PQ divided by 18p.
5Q.
Q. Star one Q.
Star Q.
Q.
All right. Anybody else? Anything?
5Q.
So look at it carefully. We see that the P cancel out, right? With each other. 18 divided by 18 is what? 1, right? Anything divided by itself is 1. So as somebody said, somebody say you're left with 1Q. But we don't say 1Q. We just say Q
It's Q.
because it is understood that 1 is in front, right? So you're not wrong, but we just say Q. Right? So we basically use this Q. Just like how we use this 2. But in this case, we're using Q and we multiply it by the numerator. Right? So it can be 5 times Q is how much? Anybody? 5 times Q is what? 5Q.
5Q.
So question. Can we add 14 plus 5Q? Can we add 14 plus 5Q? Anybody? Prudence?
No, sir.
Tyra?
No, sir.
No, sir.
Why?
Because they're unlike term.
Good. One is a constant or one is a number, or one is you're dealing with a Q term. So they're not the same. They're not same terms. So it's unlike terms, right? So the answer will remain as 14 plus 15Q. Sorry, 5Q. Divided by 18 PQ, right? So I know you're accustomed using X and Y, but in some cases you gotta know to use PQ, Z and all these things, right? So this here isn't difficult. You just gotta practice and your algebra skills and develop. All right. So I'll give you guys one more to do, right? In 4 minutes. In 4 minutes, you complete it just to ensure that you know you get all the concepts when it comes to algebraic fractions. And then we move on to something new, which is factorization, right? So take this down. Think about it, and then we work it together, right? So we get like 2 minutes remaining. So when it cut off, you just come on back, and then we work this one here. Right? If you gotta drink water, refresh yourself, and then we start the next session. So take this down, and then we work it together. So just in case some persons understand what it's saying, so it's 5 divided by x minus 4 in bracket plus 3 divided by x plus 3 in bracket. So remember, the first thing you need to do is to find the LCM. So guys, I'm gonna show you guys how you just find the LCM using expressions like this. And then it's basically the same procedure. But in this case, you gotta know to remove bracket and so forth, like what we did in the last class, right? So nothing too difficult. The things that you know, is just you gotta know how to apply yourself. So we have less than 1 remaining. Make sure you come on back, and then we work this together.